Electricity and Magnetism, written by David Dreyer. Introduction. Have you ever watched lightning during a big storm at night? Did you know that a lightning bolt is a natural form of electricity? But most electricity is made by people. They turn on a light. You are using electricity made by people. Electricity has become a very important part of our lives. It's hard to imagine the world without it. Magnetism is also a familiar part of our world. Perhaps you have played with magnets. Magnetism is closely related to electricity. This book will teach you about electricity and magnetism. It will also explain how they are connected. What is electricity? You just learned that electricity can be produced naturally. It can also be made by people. But what is electricity? It is a form of energy. Energy is what makes things happen. For example, the energy is in sunlight makes plants grow. Electricity comes from atoms. Atoms are very tiny particles. Everything in the world is made of atoms. Inside each atom are even smaller particles. They include ones called protons and electrons. Those particles have a feature called electric charge. Protons have a charge that scientists call positive. Electrons have an opposite charge called negative. These charges are the source of electricity. In diagrams, protons have a plus sign on them, and electrons have a negative sign on them to show the charges. Neutrons have no label because they have no charge. This carbon atom has 6 electrons, 6 protons, and 6 neutrons. Electrons circle the nucleus. Electrons quickly orbit or move in a circle around an atom center. Charges of the same kind repel each other. That means they push each other away. Charges are opposite attract each other. So 2 protons or 2 electrons repel each other. But a proton and an electron are attracted to each other. The number of protons and electrons in an atom is usually equal. Because the charges are equal in number, they cancel each other out. The atom is neutral, meaning it has no charge. An atom can gain an electrical charge. It can do that by getting its child electrons. It can also do it by losing electrons. Atoms can gain or lose electrons when they contact other atoms. If an atom gets extra electrons, it has a negative charge. If it loses electrons, the protons will outnumber the electrons, so the atom will have a positive charge. An atom that has charge is called an ion. An atom with more electrons than protons is a negative ion. An atom with more protons than electrons is a positive ion. Positive and negative ions. Positive ions have more protons than electrons. Negative ions have more electrons than protons. The 2 kinds of electricity. There are 2 kinds of electricity. There are static electricity and electric currents. Static electricity. Static electricity is caused when particles of positive charge get separated. The 2 kinds of particles are attracted to each other. When the attraction becomes strong enough, the particles quickly stream back together. Lightning is caused in a storm cloud when particles of opposite charge build up in different areas. When the groups of charges get large enough, they flow rapidly back together. That causes a lightning flash. Wowzer! Lightning heats the air around it to about 13,000 degrees Celsius, about 54,000 degrees Fahrenheit. That's 5 times hotter than the surface of the sun. Lightning also causes the air to expand violently. That is what causes thunder. Most lightning occurs up in the clouds, but sometimes the separation of charges happens between the ground and the clouds. Then particles then flow down to the ground. This is the kind of lightning that strikes buildings and trees. You can make a park by scuffing your shoes on the carpet when the air is dry. Doing that causes your body to pick up electrons from your carpet. Your body now has a negative charge. If you put your finger near a metal object, a spark will jump from your finger. Rubbing a balloon on your hair can create a similar effect as scuffing shoes on the carpet. Electric current. An electric current is the flow of electrons through a material. Materials that carry a current are called conductors. Metals are the best conductors, so electrical wires are made of metal. Most wires are used to carry an electric current are made of copper. Materials that do not conduct electricity are called insulators. Rubber and plastic are both good insulators. Most electrical wires are wrapped in the rubber. The rubber prevents shocks. Insulator, conductors, insulators, conductors. Some tools have plastic or rubber handles to prevent electric shock. An electric current needs a complete path in which to move. This path is called a circuit. If a circuit is broken, the current stops flowing. Closed circuit. Open circuit. With the circuit open or broken, electrons can no longer flow, so the light bulb does not light up. An electric current pushes against a force in a wire. That force is called resistance. Resistance causes a loss of energy. The lost energy is released as heat. You've learned that there are two kinds of electricity. There are also two kinds of electric current. They are called different current and alternating current. Batteries are DC. The wall outlets in your home use AC. The electrons in a DC circuit always move in the same direction. The electrons in an AC circuit move rapidly back and forth. Both kinds of energy current create a flow of electrical energy. That flow moves very fast. When electrons start moving in a circuit, energy fills the entire circuit right away. This explains why a lamp lights up as soon as you flip a switch. Measuring electricity. Electrons need a push to get moving in a wire. This push is called voltage. Voltage is measured in units called volts. In most cases, the more volts an energy source has, the greater the push and flow of energy. Most flashlight batteries have just 1.5 volts. House wiring is about 120 volts. The flow of current in a circuit is measured in units called amperes. These units are usually called amps for short. The more electrons that are in motion in a wire, the higher the number of amps. Another measure used in electricity is the watt. It measures how fast electricity energy is being used. Batteries and outlets have different voltage levels that reflect how much power they can deliver. What produces magnetism? As you have learned, electricity and magnetism are related. They are two parts of a force called electromagnetism. Magnetism comes from the electrons in atoms. The electrons spin like little tops. Every electron has an invisible area of magnetism around it. This area is called a magnetic field. In some metals, the spinning electrons turn each atom into a tiny magnet. Those atoms can be made to line up in the same direction. Then the entire piece of metal becomes magnetic. Most magnets are made of iron. Magnets are strongest at the ends. These ends are called poles. Like Earth, a magnet has a north pole and a south pole. If you cut a bar magnet into two pieces, each piece is a new magnet. Both of the new magnets have a north and south pole. A magnet's poles have like positive and negative electrical charges. Two south or two north poles repel each other. But the north pole of a magnet is attracted to the south pole of another magnet. A magnet is also strongly attracted to iron and steel. That is because its magnetic field creates a magnetic pull on the atoms in the metal.